Hello everyone, good morning, good afternoon, good evening, dear authors and invited guests. Welcome to a technical session 7A. My name is Richa and I'm the moderator of this session. On the behalf of the Global Knowledge Research Foundation, it's my great pleasure to welcome you to the 7th International Congress on Information and Communication Technology through Zoom. Further, as you are well aware, you have been facing a new normal situation while overcoming the pandemic. Hence, the conference has been shifted to the hybrid modes. We are very thankful to everyone who present on this digitally platform to go along with us and making this conference more productive. Also, we wish everyone and their families to a protected time. We hope you will enjoy the knowledgeful and interactive digital session. Also, there is a special note for all the presenters. You will be given 10 to 12 minutes for presentation and 3 minutes for question answer. And after 10 minutes, I will raise a gentle reminder to conclude the presentation. And I request while the presentation is going on, other participant kindly be muted. And there's another request to all the participants that you all are stay connected with us till the closing remarks. If you have any query and any updates, kindly write it to me in chat box. Just before we get started, I would like to introduce our chair of this session, Dr. Navneet Sharma. Dr. Navneet Sharma, he is an associate professor, Department of Computer Science and IT, IIS University, Jaipur, India. Research work on e-commerce, cloud computing, network securities. More than 25 research papers published in various international journals. More than 30 conferences attend all over the India. 17 years of teaching experience of UG and PG classes, associate with various research associations and universities and consultancy services. Thank you so much, sir, and welcome to you, sir.
Thank you, ma'am.
Now, sir, this is all over to you session.
Okay. Thank you, Richa, ma'am, for the nice introduction. Let's start with the first paper. The paper presenter is Mohammad Rasudul Hassan, and the title for this paper is Android Malware Classification Addressing Repackaged Entities by the Evaluation of Static Features and Multiple Machine Learning Algorithms. So now I invite the paper presenter, Mohammad Hassan. Please complete your paper within 12 minutes. Okay, the next 3 minutes would be for the question answer session.
Okay, sir. Thank you, sir, for giving me this chance, and I'm not sharing my presentation slides with you.
Is there any issue?
No. Are my slides visible, sir?
Yes, now it's visible.
Okay, thank you. Let me start my presentation then. So today I'm going to talk about my paper, which is Android malware classification addressing repackaged entities by the evaluation of static features and multiple machine learning algorithms. So I am Rashidul Hassan. Currently, I'm a PhD researcher and a graduate student at the University of Nebraska-Lincoln. I used to work at Cybertrace Incorporated and Zerocopter. So if I talk about malwares are infecting us everywhere. There are ransomwares, rootkits, trojans, botnets, and spywares at every part of the world, affecting us everywhere. And if I see an infection ratio, this is a calculation of 2020. Sorry. In 2020, like the most number of malicious infections were found in Europe. In Asia and in North America, and at least severely infected cases were 58% and minor infections were 42%. So malicious vectors like rootkits, botnets, they're everywhere. They're affecting us everywhere. So actually the research is concentrated with Android malwares because the increased popularity of Android devices and the large market share of the Android devices actually inspires malware developers to repackage malwares and launch them in different forms. So as Android devices are increased, malware developers are developing and relaunching different type of malwares actually. So the concept is basically malware developers are developing malwares and sending them in the market, and it is being detected by antivirus engines. But however, the malware developers are more clever. They're taking the source code and repackaging the malware. And when the malware is repackaged, they are not detected. So the for research focus and the concentration is to detect those entities which are repackaged, which are not detected by the means of source code. So the proposed model represents relatively newer approach to approach that repackaging formula on existing implementation. And around 70 malicious patterns were discovered, like taken from different references, and 14 at least were discovered from the self-discovery. And there are more, of course. And there is a practical implementation of the tool which has been developed to check the model and how it works. So if I talk about the abstract is about, it's like a relatively newer approach. I have used the custom bag of words. Bag of words is an algorithm. I'll talk about it. I have used machine learning to verify the model to address the repackaging issue, and the model actually performs better, at least 0.77% better than the existing implementation on this field. So as I've said, when raw code is repackaged, malicious fabrication and detectability, addressing this issue has been the focus of this research. Okay. So malware developers are focusing on Android platform. And in multiple cases, Google Play Store actually sometimes used to accept the malicious applications. Sometimes, like now, Google Play Store, I think, detects malicious applications, but as I have mentioned, that they are repackaged. When a malware is detected by an antivirus engine or a web entity or a web engine, it is being repackaged and it is relaunched again to the market to avoid detection. So this has been the core focus of the research. So this is the literature review, how the research area was selected and how actually I concentrated to work on this area, found the research gaps, studied different papers on this field and looked for similar papers, research gap, and started working on it. So there are some papers I focused. So actually I worked on a similar paper previously. I was the first author of the paper, and this work specifically is an enhancement of that work. And specifically my contribution, I think, is like I have added more self-discovered pattern to the work. I have made the model better, and I used multiple machine learning algorithms to the work. So these were some selected papers on the literature review. There are more papers in the references. So yes, this was the base paper. So if I go to the base paper, I was also the author of the base paper, if I talk about it. So the base paper actually only used one machine learning algorithm, which was SVM, to assess the efficiency of the work, and the implementation of the model was based on it. And the base paper also used the M0 droid dataset. I also use the M0 droid dataset, but what I try to do, I try to take some external data, not a lot, just a few of them, to see how the things actually work. So I actually basically use the M0 droid dataset from the paper. And in the base paper, there actually decompilation of source code, text mining, classification, these things were used. I also used the same thing. The bag of words algorithm was implemented. I tried to modify the scripts better so that the performance can be better. So if I talk about the research gap in the base paper, on the previous research in this area, specifically concentrated to this field, SVM was used to only measure the efficiency, only one algorithm actually could not give a better, I think, throughput. And again, pre-instantiated patterns from different papers and references were collected, and more focus was given to those while developing the model. So less malicious patterns were self-discovered in that research work. And in my work, actually, I concentrated to focus on more machine learning algorithms, more self-defined, self-discovered malicious patterns. So the end product can be made better. So this is my methodology, how I actually did work. I collected the data set, got the APK files. From the APK files, collected the DEX files. And I used the engine VirusTotal. VirusTotal has a unique engine called VT-graph. So I used the VT-graph to get the code location of the infection of the APK file, and got the jar file from their class files, got the raw source codes, And then I compiled the first data set. So in the first data set, I took consideration of fresh keywords and malicious keywords, and I used the bag of words algorithm with Python so that I can categorize fresh and malicious keywords. And when my vocabulary was actually more concise, I did a second phase of machine learning implementation. And finally, I received the results to make the model. So this is something, an additional assessment. This is a virus total. Like this is the website virus total. When you give something, they will see show that this is a malicious application, or if it is not, it will not show. Because see this in this specific scene, something is detected as malicious by 14 antivirus engines when I'm giving the dex file. So when I'm giving the same class, like class files in raw source form, that is being not detected as malware. So same thing is detected as malware and not detected as malware. So this is the area I concentrated to work. So the VT graph of the virus total actually shows me where the infection is coming from. So with the help of this tool, what I tried to do, I tried to go to the files, collect the raw source code, and actually merge the raw source code to do my work. So if I talk about the machine learning process, it was completely with raw coding with Python, and a tool named scikit-learn was used. And basically, yeah, I actually measured these things like accuracy, precision, recall, and F1 score to measure, to develop the model. So if I talk a bit about bag of words algorithm, it is an algorithm which actually takes consideration of the words, and it tokenizes, counts the word, and finally normalizes the words. So bag of words is basically collection of data from the source. It generates the document vectors, it sorts words by the means of counts, frequency, and generates the hash. And it designs a vocabulary to address the total data to managing the vocabulary-based requirements. So if I just give an example, what is bag of words? You suppose there are two sentences, I'm tokenizing both of the sentences and counting the sentences, tokenization, counting, and then I'm setting the frequency, how many number of times these words actually appear in the sentence. So I do a disjoint union of the sentences to understand how this is working. So if I implement it with Python, this is just to give you a general idea of a bag of words. So implementing with Python, this how it will look. Sentence will be taken, tokenization, sequencing, and counting will happen. And if you give something, bag of words actually can identify based on strings. So what I did, what was my customization, my contribution on the process of collecting data, I used a Python script to process and clear the source by the means of fresh and malicious keywords. And I tried to extract each of the words from like the source code based on my malicious and fresh keywords, process text in Python code. And I compared the vocabulary, and if it was present, like it will be represented by 1, or not present 0. By like comparing, I mean, suppose you have a malicious code or something, and I give my input a malicious function. So if it is present in my whole vocabulary or something, then it will be presented as 1. If it is not present, then presented as 0, something like this. So filtering the data set, fresh keywords and malicious keywords, these were something fresh keywords. If something is found, some fresh keywords are found in my vocabulary, then these things were not malicious. And if these are malicious API calls collected from different references, if these things were found, then the method or the specific code were taken as malicious. So these are API calls, functions, classes that I've taken, more classes. Yes. So if I talk about the result and discussion part, with SVM, I have at least 96.42% accuracy, and same F1 precision, recall, and F1 score. So like there can be a question why the precision is same as like recall and F1 score, because I was working with raw source code. So relevantly, I think the precision was good, because as I was completely working with the raw source code, I was pre-processing that text with different levels. So I think the accuracy is better in SVM, good in SVM. So I used other algorithms like decision tree, have a 94% accuracy, random forest 92%, logistic regression 95.61%, and multimonial NBs like 95.6%. So in the base paper, in the previous base paper actually also used SVM, and they had like 95.6% accuracy. I have a 96.42% accuracy. I won't say that this is a very big contribution, but at least what I try to do, I try to find the malicious models and try to make the model better. So as a result, I got a better accuracy than the existing. So it proves that like if this work is taken further and then like this can be something taken to industrial level. So in this work, actually, I tried to find 14 external malicious patterns, because these malicious patterns actually complementing the pre-existing malicious patterns which were taken from the references. So that is why by the behavioral changes, actually, I categorize them as malicious. So these are some malicious external patterns which were found. So this is a tool which was developed based on the model. So in the tool, if you give a source code, if there is a malicious functionality, it will be sorted as malicious or malware, or it is not, then it will be sorted as not malware or not malicious. So conclusion and recommendations. So the finding was basically on addressing and repackaging of malwares by the static analysis and automating the static analysis process and classifying and comparing with 5 different algorithms. Pattern identification was based on API calls, functions, methods, this type of things. And I have at least 96.42% accuracy, which is better than the relatively implemented approach. So the future research direction of this work is huge. This can be implemented in antivirus engines like industrial levels, and like if AI-based implementation is can be introduced to the work, self-discovery of malicious patterns can actually make this work better. So these were some references for my work that I used. So thank you for your time and seeing my presentation. If you have any questions, feel free to ask.
Yeah, thank you, Mohammed Hassan. Any query, any question from the audience?
Yeah, hello. I was wondering, it seemed like you used Python bag of words here. Did you appreciate the software package you were using there, or did you have any like complaints with it? Or?
Complaints, actually, I used Python scikit-learn. So I did not actually I used raw coding to actually pre-process the text. There were a few dependencies while actually I was pre-processing or doing a lot of like working with a lot of codes. However, I think if you use something like pre-instantiated tools or some automated tools, then there can be issues. But if you try to customize the script, then I think you can customize in different ways.
Great, thank you.
Thank you.
Yeah, any other query? Any other query from the audience? So thank you, Mohammed Hassan. You have presented your paper very nicely. One question, how you are calculating that your accuracy level is 96.42%? Is there any specific tool for calculation?
Yes, yes. Actually,
your data.
Actually, I used a tool. I forgot. There is a tool of. There is a specific tool to measure the accuracy. Actually, yes, I use that tool also to measure my accuracy. I forgot to mention the name of the tool. There is a tool from New Zealand University. I specifically forgot the name. I have to see my paper again.
No issue. It would be better if you can include that tool in your presentation.
Okay. Thank you, sir.
So all the best for the next time. No issue. Yes, any other query?
Sorry for that, sir.
No issue. You have nicely presented your topic and your contribution also. Thank you very much.
Thank you, sir. Okay, sir, I'm stop sharing my screen.
Yeah, please. So our next presenter with us, Ivan Nadialov. Yes. So he will present the paper on the topic network modeling, a convenient way to study IP networks. I welcome Mr. Ivan. Please
Hello.
start your presentation.
Are you seeing the presentation?
Yeah, it's visible.
Okay. And hello, I'm Ivan Nedyakov, and I'm going now to present our work. As you know, the IP networks are now constantly entering our daily lives. Almost all household appliances now has the ability to connect to the internet for remote management. And almost any device now can be connected to the internet. In addition, the internet service providers are constantly providing new service to the customers, higher speed for the internet access, the number of the channels of IP televisions is constantly growing. HD channels are constantly adding, 4K resolution channels are constantly now adding. Interactive IP television is offered. The number of streaming services is increasing. In order of all these services to be usable for the users, the IP network must be prepared for them. And this is achieved by continuous researches. Now, in order to be able to make these researches, it is necessary to implement an experimental IP network. But this is too expensive because not every school or education institution can afford this, or the researchers will not be allowed to configure and reconfigure a working IP network. So therefore, the programs for modeling of IP networks come to the rescue. And the advantages of using these programs are no cost for purchases of network equipment, ability to continuously reconfigure the model network, which is impossible when the network is working and operating, ability to design and test the IP network in secure virtual environment, working with disk images of real operating system, of real network devices, ability to transfer the already built and working IP network in a virtual environment. Of course, there aren't drawbacks of using software for modeling of IP networks, like the working station where the IP network will be modeled must have serious computing abilities, and some of the softwares for modeling of IP networks are not free. Some of them is free, or if you want to use additional application, you must pay for them. In our work, we are using the GNS platform. Here, this is the first modeled IP network. Why we're using the GNS3? GNS3 is a free platform. It can use disk images of most of the most of the network devices from many of the what was the word now? Famous, let's say this word, famous producers of network devices. It can be connected, the modeled network in GNS3 can be connected to a real network. GNS3 can be can be collaborated to use with a lot of software for monitoring of IP networks. The first model that we are showing here of this network, consisting of 5 routers and 4 virtual machines, which are used for what was the word? It was used for not members. It was used for, they are used for the users of the asterisk IP telephone exchange. In the model network, only VoIP traffic is exchanged. And these are some of the results of the model network. The idea of this model network is to check if this kind of IP network when using the performance of this IP network will be better when using MPLS technology, or will not be better when using the MPLS technology. These are the results when the MPLS technology is not configured, and these are the results when the MPLS technology is configured. As can be seen from the results, there is slightly improvement in the performance of the IP network, but not so great as expected. For this model network, in a few words, it can be said that the voice streams the model network is working, the voice streams are successfully and smoothly exchanged in it. The use of the MPLS technology together with the OSPF routing protocol does not lead to any significant improvements in the model network. The other network that we tested is a smaller one, but the new feature in it is this model network is connected to the internet by using this module. The routing protocol is OSPF, as can be seen in the results. Here we have a successful full exchange of HTTP traffic, because we tested downloading a large file from a server in the internet. Here we can see the generated traffic in the network, in some of the routers, and the top used protocols in this network. And here are the other results from the same model network. In summarize, for this model, a working model of an IP network has been created in which successfully data is exchanged. The model network is connected to the internet, and as a result, there is a successful download of data from a remote server, which is proved by the results of the Wireshark. The ability to connect model networks to other real IP networks is one of the great advantages of using IP platforms for modeling in the study of IP network, and this is the why we are using GNS3. The conclusions: using model network instead of building real test one has many advantages, such as less financial cost, working with disk images of real operating system of real network device, convenience, possibility for continuous reconfiguration of the network device, and testing of the model network, which is impossible to do in a working real IP network. Ability to modeling an entire working network, IP network, for testing and research. The drawbacks are very high computing capabilities of the workstation where the network will be modeled. Some platforms for modeling are not free, or that the additional tools for them are paid. Achieving a working IP network model takes a long time, and this time depends on the complexity of the network. Practical examples show some of the opportunities offered by the platforms for modeling of communication network, and the GNS3 platform is presented. And again, why we're using GNS3? Because it offers the ability to connect to real IP networks. It works with disk images of real operating system of real network devices. It can work with additional tools for monitoring of IP networks. And shortly, this is.
Thank you, Ivan. Is there any question from the audience? Anybody wants to ask something? Any query or any question from the other viewers? Okay, Ivan, I have one question.
Yes?
Am I audible to you?
Please.
I'm audible to you?
Yes, I hear you.
Okay. So my question is, why you are using GNS3 only?
Because, like I said in the presentation, it's free and it has the ability to connect to real IP networks, and it uses real network devices. I was trying to use another software, ICICT, but some of the abilities of ICICT, like the one I'm using, the ability to connect to real network, it's not free. I must pay for the version to use this ability. And because of that, we are now using only GNS3.
Okay, thank you, Ivan. You have nicely presented your topic on the network modeling. So, and try to improve your results with the other simulators so that you can validate your model very nicely.
Okay, thanks.
Okay, thank you so much. Our next paper presenter is Jonathan.
Yes, okay.
Welcome, Jonathan. Your paper title is a prototype based on LoRaWAN network for storing multivariable data
Yes.
oriented to agriculture with limited resources. Okay, so you may start your presentation.
Okay. Good afternoon, everyone. My name is Jonathan Nyakasha. My presentation is entitled Prototype based on a LoRaWAN network for storing multivariable data oriented to agriculture with limited resources. The authors of these papers are Jonathan Nyakasha, Steven Castro, William Oñate, Gustavo Mesillas. Contents. My presentation has the following order. Number 1, introduction. Number 2, methodology. Number 3, results. And number 4, conclusions. Study problems. The problems that have been studied are: number 1, heading for digitation, which is about the evolution of technology. Traditional agriculture is about the evolution of this agriculture. Lack of technology to apply new methods. Next, the devices used in the LoRaWAN network are the following. We have 3 nodes. Node number 1 have the sensor of temperature, humidity, atmospheric pressure, and luminous intensity with the respective model. For example, in temperature, have the model D18B20, and the humidity have the IPC28, and the other sensors. In node number 2, have the sensor of environmental temperature, environmental humidity, and solar radiation with the respective model. In humidity and temperature, have the sensor HD32, and the node 3 have a sensor of vegetation index. That sensor needs artificial vision, and your model have a Raspberry Pi 0 and camera. Architecture consists of 3 nodes, each one with your sensor. In node number one have a 4 sensor, node number 2, 2 sensors, and node number 3 have a Raspberry and camera. With the gateway from the LoRaWAN network. Later upload to the TeamSpeak page and the Team Network page. The vegetation index method. The method to obtain the vegetation index has the following process. Number 1, save the photo to the cultivation surface. Number 2, extract the RGB channel, red, green, and blue. Apply the CIVE method, the color index of vegetation extraction method. This method extracts the color for the vegetation and removes the unwanted. And binary photo to the free photo. Number 4, apply the formula for the vegetation index, that is, for a matrix of 1 and 0, 1 is white and 0 is black, add all values, divide all data, and multiply by 100%. We have a photo, the dimension of the photo had a 720 by 720 pixels. This method is in real time. And finally, conversion of image. Implement model. This is the implement model. It has the advantage of the vegetation index node, that is node number 3, that consists of the Raspberry Pi 0 with a camera which sends information to the Team Networks page and TeamSpeak page in real time. All the sensors send information to the ESP32 process. The data obtained can be visualized in TeamSpeak and the Team Networks page. Results. The data obtained can be visualized in TeamSpeak by means of scatter graphs. The story of collected data can be observed. For example, in this case, have the data of node number 2, the temperature, and vegetation index of node number 3. This table shows the average data collected by the sensor in a 12-hour period. For example, in node number 1, have a temperature of degrees Celsius, humidity 10%, and then lumens, and atmospheric pressure in millibars. Node number 2, temperature degrees Celsius, humidity 10%, and solar radiation in milliwatts and square centimeters. And node number 3, vegetation index 1%. Table shows the comparison of commercial data logger prices with the proposed system, with selling of 17 times less, not counting the node, especially in vegetation index. For example, in the proposed system, had a price of $180, and the data logger and the commercial data logger have a $1,800. We are to conclusions. The system deployment in the process fulfill the suspicability of the problems. In summary, the conclusion that can be mentioned in this project is that despite having a low cost, it has all the function of a commercial data logger, in addition to having the advantage of being able to obtain the vegetation index in real time. And this doesn't have the commercial data logger. Thank you for attention.
Yeah, thank you, Jonathan. Yes, any query from the audience? Anybody wants to ask something?
Yes, hello. I was wondering if the Raspberry Pi is doing the is running that algorithm on board the Raspberry Pi itself, right? For the image segmentation.
Yes, the Raspberry Pi Zero is the have a capacity of memory of susceptible to complete this process, and Pi 0 and Pi 3 and Pi 3B and the other Raspberries. In all the process of the vegetation in the method is in real time, and no problem to the capacity of the Raspberry.
Jonathan, can you come on to the previous slide, the analysis one?
Yes.
The second last slide. Can you show me the slide? Yeah, your results. Can you explain this result within 2 lines? What is your contribution towards this paper?
Yes, well, in my case, the contribution in the agriculture have in my house, we have a process of cultivation of, in Spanish, maize, chocolate in Ecuador. And I have a me to agriculture and technology to have the process to the next level.
Okay. Thank you, Jonathan. Thanks for the contribution.
Thank you too.
You can improve your presentation next time with the proper results and the better results also. Not the proper results, but you
Yes,
can improve in more in your study. Thank you. Thank you very much.
And a good presentation.
Yeah, our next presenter is Ms. Carrie. The topic of the paper is the low energy responses of spike train encoded data. So welcome, Ms. Carrie. You may continue your presentation.
Thank you. I'll begin to share my screen now. Is the screen visible now?
Yeah, it's visible now. You may start.
Thank you. I'm here today to talk about the low energy response of spike train encoded data. My name is Carrie Hartley Segal, and I am a computer engineering graduate student at University of California, Santa Barbara in the United States. An introduction. Noiseless digital circuit design is predominantly implemented using static complementary metal oxide semiconductor, or CMOS, fabrication. Boolean logic gates, such as the 6-OR gate, are designed into standard cells, shown in the layout to the right. The standard digital design flow uses static timing parameters for specific fabrication processes, which have statistically predictable behavior from intensive simulation, fabrication, measurement, repeated multiple times. An alternative to this is to embrace alternate design styles which are intrinsically connected to the physical characteristics of the process they are implemented in. In this work, an address event representation of data is created based on a predetermined Markov chain. Review of preliminaries. The information content of a message is described using Shannon entropy, a term which measures how much information is produced at some rate from an information source with symbols present with probability summing equal to 1. The way the overall probability, P, is distributed across the symbols from the alphabet determines the classification of Markov chain the message could come from. Markov chains can be classified using the ergodic hierarchy. A non-ergodic Markov chain has state like state number 2, which if you initialize into state number 2, would transition you to either a state shape, which loops along this path, or which loops along this path and renders it inaccessible to the entire system of states. A simply ergodic Markov chain is one from which any initialization starting state will eventually, at some point in time, be able to transition to the other states that are present in the system. And a B-system ergodic Markov chain is a Markov chain where it is possible to have a transition from one state to the next and back again, which means all states will be visited equally over a long enough time period. The Markov chain classification is used to specify an alternative computation based on embedding information into space and time to create a race logic circuit. Race logic circuits for non-binary digital codes. A race logic circuit with A equals 3 symbols, fast, medium, and slow, is shown as voltage timing waveforms. A 1D compute grid operated on stationary program signals Q and R is used to configure the timing path of an incoming rising edge, upper left corner, which eventually leaves the grid as a race octagon, lower right corner, encoded with data and timing information corresponding to a non-binary digital signal representative of the possible computation outcomes for Q and R. But how is a race logic circuit described as a Markov chain? First order binary Markov source. The CMOS circuits used to implement race logic are concerned with the measurement of a transition 0 to 1. The physical measurement has transition probability equivalent to a first order binary Markov source, shown here. For the binary source, the stationary probability vector is represented with mu0 and mu1. The reset state is taken from the 2 binary options. It is the state corresponding to the stationary distribution. P, chi equals 1, equals mu0. Or if the probability that the reset state is 0, the probability of observing mu1 is 1. For a non-binary Markov source, a first order non-binary Markov source that is simply ergodic is one that has at minimum a non-zero probability of transition in each row. Furthermore, to establish a baseline entropy to energy equivalence, a first order Markov source has B system ergodicity if for each P in the probability chi is equal to 1 over chi squared. The entropy cost to access the reset state increases with the entropy of the order of the Markov chain, 1/2 log n, where n is the number of possible symbols used by the specific implementation of the non-binary digital encoding. closer to theoretical energy reset cost. To achieve a closer to theoretical reset cost, expand one-dimensional to two-dimensional races. A 1D race has a single start and endpoint with stationary computation signals in vectors R and Q. A 2D race has multiple start and endpoints with a simple stationary communication system modeled after a simply ergodic and B-system ergodic Markov chain, forming a shared racetrack. Main results. With analog signals, an electrical communication is a continuous function, V of t. When the conversion is made from analog to digital, the selection of A chi is performed. With selection of Markov chains with larger alphabet sizes, high information capacity data transfer is possible. The selection of A chi for 22 through 16 is selected for CMOS layout compatibility, with 5 metal layers typical for a mixed signal process, indicating that 25 is the maximum number of connections a typical standard cell could sustain. Mutual information of non-binary digital Markov chains. Mutual information comparisons for A chi greater than 2 demonstrate how, at short code lengths, the information estimation is much higher because the estimator is uncertain if the data belongs to B-system ergodic or simply ergodic classification. Here we have a plot of mutual information for a binary signal, which is the typical estimation of 0. For a non-binary digital signal with A chi equals 16, at short code lengths, the mutual information is much higher. It's closer to 8. And finally, for a non-binary digital signal with A chi equals 32, we have mutual information slightly above 8, indicating that an alphabet size of A chi equals 22 would be able to transfer information around 8 bits. Experimental results. The representation shown to the left of the time series lists the data formats the movie is maintained in and the average size of that data in bits. The original movie is 20 megabytes. And this is the frames as they progress over time. The encoded output from the 1D race logic is 80 megabytes. So it increases in size at first because it's less compressible here, because the data is changing pretty rapidly across the individual bit pattern of the data. But the encoded output from the 2D race logic grid overlaid on top of the encoded output from the 1D race logic grid is less than 1 kilobyte. Conclusion. Comparing an address event representation of an image frame or a series of image frames versus a PNG or a series of PNGs, like a movie type, the address event representation for a 2D race logic circuit is order of magnitudes less. Thank you to ICICT 2022 reviewers and organizing committee.
Yeah, Kerry, thank you very much. You have presented your topic very nicely, and I appreciate your research work. So I just want to ask one thing. Which tool you are using for this process?
I'm using the OpenSky process development kit for the Skywater 130 nanometer process, which is a recently released ASIC open source toolchain. And I use NGSpice for simulations at the schematic level.
Can you justify your tools? Why you have selected these tools only?
Yes, the predominant reason for selecting the the open source tool chain is the ease of sharing the results from these publications. Also, the fabrication cost for 130 nanometer is significantly lower than if I were to pursue lower technology nodes like 22 nanometer.
Great. Thank you. Thank you so much.
Thank you.
Yeah, our next presenter with us, Marita Maris, on the topic machine learning analysis in the prediction of diabetes mellitus. Yeah,
Yes.
Marita?
Yes. Okay, one moment, please.
Yes, you may start.
Okay. Good afternoon, everyone. I am pleased to present the research entitled Machine Learning Analyzing the Prediction of Diabetes Mellitus, a system review of the literature. The authors are Víctor García Ríos, Michelle Cabanillas Carbonell, and your speaker today, Marieta Marres Albano. This is the outline of the presentation of the article. Well, introduction. In recent years, diabetes mellitus has increased its relevance in the global landscape. Studies show that around more than 381 million suffer from it, and that approximately 45.8% have not been diagnosed yet. Currently, due to COVID-19, people suffering from diabetes are the most likely to suffer severely from COVID-19. It is because of this that an early diagnosis is important at where the implementation of machine learning takes a vital role. The objective of this article is to analyze and publish the presence of machine learning models to detect and predict diabetes mellitus and its types. This article aims to provide an analytical summary based on research conducted in different countries around the world in the last 4 years. Methodology. The article was prepared using the systematic review of the science literature, a process that allows the collection of relevant evidence of a given topic where eligibility criteria are established to obtain answers to the research question formulated. The proposed research questions are as follows. Question 1. Which diabetes mellitus prediction models have shown the best results according to performance metric over the past 4 years? Question 2. Which tools or languages are the most widely used in the world to develop or implement machine learning models for diabetes mellitus prediction? Question 3. Which countries has the most research related to prediction of diabetes mellitus being conducted in the last 4 years? And question 4, what type of diabetes mellitus has had the highest amount of science research focus and prediction with machine learning worldwide? For the research strategies, we say in the question posed, an exhaustive search of articles published in the main diabetes, such as IEEE Explore, Scopus, Science Direct, IOP Science, EFS co-host, and Wiley was carried out, from which 683 science collect, all were analyzed, from which 3 duplicate articles were discarded, then 55 articles were selected, excluding 628 according to the exclusion criteria and which did not contribute to answering the research questions. Results and discussion. For the question 1, most of the articles analyzed in this review use accuracy as a metric to evaluate their models. The result of time allows us to use this metric as a reference to identify the best performing models. According to the table, it can be observed that the super vector machine, random forest, and external learning machine models have obtained the best performance with 100%, 99%, and 99% accuracy, respectively. Additionally, the super vector machine and random forest model are the most used models by research. Question 2. In the fifth figure, it can be seen that most of the research do not indicate the development environment or their models. However, a representative number use the free software platform, Weka, which is described by all the authors as a simple and intuitive tool. The second figure shows the graphical use interfaces are more used the programming languages. However, we highlight that in one of the analyzed articles where 100% accuracy was obtained. The MATLAB tool was used in which the M languages is used. Question 3. According to figure articles by continent, the articles analyzed in the present review come from the continents of Asia, which is in first place, North America, Europe, and Africa. This result indicates that development of machine learning models for the prediction of diabetes mellitus is a recurrent research topic almost all over the world. The vast majority of research is conducted in Indian countries and secondly in China. Figure articles by year and database manifests that in the last 4 years, 2018 to 2021, there is an increasing amount of research related to diabetes mellitus prediction. Between 2020 and 1999 and 2020, there was a great variety of publications, especially in IEEE Explore databases, followed by Scopus, and in 2021, the number of research is growing. For the question 4, according to the table, there are a greater number of investigations that not focus on a specific type of diabetes mellitus, but it can also be seen that there are a significant number of investigations that seek to predict type 2 diabetes mellitus. Furthermore, in almost all the databases consult for this review, and at least one research related to prediction of diabetes mellitus was found. The result indicates that in the most important science databases, research on the development of model for the prediction of diabetes mellitus is relevant. In figure, articles by dataset shows that of all the articles analyzed, the vast majority have used the PIMA India diabetes dataset, and indicated that the information provided by this dataset is highlighted, valued by research, and it relates to the fact that there is a greater amount of research of prediction models for type 2 diabetes and gestationality diabetes, because the variables in this data are identified as determinant for the prediction of the mentioned types. Okay, conclusions. In the present study, 55 articles were selected to identify the most commonly used machine learning models and to identify the best performing machine models for diabetes predictions is in other review studies. Our contribution is to have selected such metrics according to recommendation for numerous other application studies, identify the most used development or implementation tools, and most used datasets. We also identify the largest amount of research according to type of diabetes countries and recognized databases. And like recommendations, Based on the results obtained, it is recommended for future research within the scope of this review, the work and of the development of predicting models with a super vector machine algorithm due to the good results obtained, as well as to consider accuracy as a metric to evaluate model performance and to use MATLAB or RStudy as development tools. Thank you very much.
Thank you, Marita, for the nice presentation. There is one question from the audience. Sorry, there are two questions. So this is the open platform to ask the questions. The first question is from Gustav Pezo. Can you ask your question?
Okay.
The question is written on the chat box. I'm just
Just
asking the
one
question
minute.
from on the behalf of the
Okay.
other participants. Why did you
Uh,
apply this methodology, and what difficulties did you encounter in this research?
Okay. Well, in this case, because it allows you to gather relevant evidence on our topic by applying eligibility criteria to the articles, classify them, and generate tables and graphics that help the use answer the research question posed. And the main difficult was to systematize the information of all the articles collected, since was a considerable amount. For the second question.
Yeah, I think now you got the answer, Gustavo Pezzo. Okay, the second question is based on your research, which database do you consider to be the most important for machine learning research related to diabetic mellitus?
And we consider in first place IEEE Explore, since under the selection criteria we use it allows us to identify articles not only of application but also of implementation in real environments, followed by Scopus and Science Direct.
Is there any specific data set which you are using for your result analysis, Marita?
Just in this case, we use it a special IEEE Explore, and is a main databases we use it for this article.
It is the primary data or the secondary data?
Sorry?
The data which you are using for your analysis purpose is the primary data or the secondary data, which you are collecting from different sources?
Yes. Well, and you said the follow the databases is Scopus and Science Direct, and IEEE Explore for this article. And we use eligibility criteria for exclusion and inclusion articles for this investigation.
Okay, thank you very much. Thank you, Marita, for the nice presentation. You have
Thank you very
explained
much.
all the topics very nicely. Thank you.
Thank you.
Our next participant is Mr. Faisal Hadi. Is from Australia, and the topic for the paper is the different applications and the technologies of IoT. So yes, Mr. Faisal, you may
Yeah,
continue.
thank you. Just give me a few seconds. Can you see my screen clearly?
Yeah, it's visible.
Yeah.
You may continue.
Hi, everyone. My name is Faisal Masmali, and I am PhD candidate at University of Newcastle. And my topic of research is IoT of IoT surface on a healthcare surface. However, my paper today, I'm going to present applications and technologies of Internet of Things. Can you see the PowerPoint in my screen, or is it different?
Yeah, it's visible, but not changing the slide.
Okay.
Yes.
Internet of Things has significantly altered the traditional lifestyle to a highly technological advanced society. Some of the significant transformations that have been achieved through IoT are smart homes, smart transportation, smart city, and control of pollution. A considerable number of studies have been conducted and continues to be done to increase the use of technology through IoT. Furthermore, the research about IoT has not been done fully in improving the application of technology through IoT. Besides, IoT experiences several problems that need to be considered in order to get the full capability of IoT in changing society. This research paper addressed the key applications of IoT, the architecture of IoT, and the key issues affecting IoT. In addition, the paper highlights how big data analytics is essential in improving the effectiveness of IoT in various applications within society. IoT illustrates a network of physical objects implanted with sensors and software that are interconnected, which have significantly facilitated people's life with an approximation of 7 billion people around the world being connected via the IoT devices. It applies both smart devices and internet to solve adverse issues in various businesses and industries, making it a vital aspect of our daily lives. Incorporating both quantum and nanotechnology, it is able to sense, store, and increase processing speed that was an
Sorry to interrupt, Mr. Faisal. Your slides are not moving.
Okay, do you see here the first slide is Internet of Things, illustrated network physical objects. There are above 7 million connected IoT gadgets in the world. Do you see that slide?
Yes. Okay, continue.
Yeah.
You may continue.
Yeah, I haven't finished this slide actually. Incorporating both quantum and nanotechnology, it is able to sense, store, and increase processing speed that was unattainable some generation ago. The application of IoT devices has significantly transformed our lives, making it more efficient in all aspects, from home automation systems and other smart systems. In the transportation sector, that has made traveling more efficient. Here a sample of architecture of IoT. It involves steps whereby information flows from sensors incorporated in things through a network and finally on to a corporate data center or the cloud, where it undergoes processing, analysis, and storage. So all the information goes from IoT or Internet of Things, the device, the sensors, to the cloud, the central cloud, and then all the data has been collected will be analyzed to make a decision. generic structure of IoT. It involves steps whereby information flows from sensors incorporated in things through a network and finally on to a corporate data center or the cloud where it undergoes processing, analysis, and storage. According to Kumar, in 2019, the critical design factors for productive IoT architecture are scalability, opens, modularity, and interoperability. So this is the generic of structure of IoT. Applications of IoT. We have smart city transport and vehicles to safeguard morals and prevent people from reaching them. Specific policies and procedures should be considered for IoT developers, with ethics laying guidelines that individual should stick to, while legislation being the limitation placed by the government to protect the quality and individuals from taking part in criminal behavior, therefore reduce problems of privacy, trust, and security of information. This is one of the application of IoT issues, is about the ethics and how laws are made to monitor these data that has been collected. Also, the fundamental drawback with IoT is incorporating many devices with varying memory, process, storage capability, bandwidth, accessibility, and reliability. This is also basic on the hardware of these IoT and how can be managed. Issues associated with IoT. One of the challenges facing IoT system is security and privacy due to the available threats, cyber attacks, and vulnerabilities. Also, interoperability or integration is the practicability and switching data among several IoT devices and systems, and therefore the heterogeneity of various technologies and solutions involved in developing IoT come about. Also, the quality of service, evaluate the quality, effectiveness, and productivity of IoT architecture, devices, and system, and therefore a good IoT platform should meet these necessities. Big data analytics in IoT. IoT has enabled better monitoring and control of the electrical network by application of smart meters with sensors that allow bidirectional communication between power companies and users on matters, faults, repairs, or decision making. Also, it has also been applied in water supply, whereby a sensor is equipped internally or externally in water matters connected to the internet and integrated with the relevant software assist in collecting, processing, and analyzing data that is essential in detecting faults and understanding water consumers' behavior. So the IoT can help actually making on-time decision, like live decision, if you have the correct data. Other applications of IoT. We have IoT in healthcare. According to Kumar, 2019, IoT is committed to providing financial benefits and development to society, which include public facilities such as water and quality maintenance, economic development, and industrialization. For the health sector, application of wearable sensors linked to patients enable healthcare provider to observe a patient condition while outside the healthcare facility. And also, as you know, about the pandemic and how the country is trying to track people who are affected by coronavirus. They have used basically IoT to track them and try to eliminate or actually maintain the spread of coronavirus. And it is based on IoT. Wearable devices are small devices equipped with sensors and relevant hardware to take measurements and reading, while their software gather and organize data about the user of, like example, GPS tracking belts. Also, amalgamation of sensor and software specialized in enterprise and assets management and computerized maintenance management system allow the development of multifunction tool that can be applied various disciplines and practices to increase the productive life of assets. Conclusion. A significant transformation is evident from our daily lives whereby the application of IoT devices and technology has significantly increased. Moreover, the current advancement in IoT have made researchers and developers collaborate in improving technology in IoT on a large scale. Also help in prevention of real-time decision with the, as you now know that the world actually is starting to launching 5G. And 5G actually, with the speed of 5G and also the small amount of lacking, it helps to make decision, and also it helps developing more based on IoT. Thank you for listening, and I am open for questions.
Thank you, Faisal. Yes, any question from the audience and the other participants? If they want to ask something, then this is the open platform for all. Yes, Mr. Faisal, I have one question.
Yes.
Can you conclude your overall research in 2-3 sentences? What is your specific contribution towards this research paper?
It's basically looking into the application of IoT and the improving of in this application, and the world has become depend on basically on IoT more and more. Like I would say this is my word. It is the IoT is the oil of internet.
Okay. So any other question? If anybody wants to ask something? Okay. Thank you, Faisal. Thank you so
You're
much.
welcome. Thank you for having me, and congratulations for putting this together, especially in this pandemic. And hopefully we'll see you again next year.
Yeah, sure. Definitely we'll meet again.
Yeah.
Thank you so much.
Thank you.
So, Richaji, with your permission, we
Done,
can
sir. We have
conclude the
completed.
session.
Yes, sir. Done, sir.
Yes. So all the 6 participants presented their papers very nicely. I think all have the good confident level for the presentation, and they have very nicely presented all the analysis part and the methodology which they have touched in their papers. So all the authors have good knowledge about their topic, and thank you all who have presented their papers, and all the best for their future endeavors. Definitely they will get great success and complete their research in their respective fields. So thank you, Richa ma'am. With these words, I conclude this session.
Thank you, sir. And I sincerely thank our author for the excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative, and all the presenter would be getting the digital certificate within 2 working days via email. And for all the papers has already forwarded to the Springer. The publication will be live within 5 to 6 months. Kindly cooperate with the team of ICICT. And I also thank our session chair for chairing this session. Thank you so much, sir. And this is a token of appreciation on behalf of Team ICICT and a Global Knowledge Research Foundation.
Thank you so
Thank you
much.
so much,
Thank
sir.
you, Richa ma'am, and the team ICICT. Thank you, Amit ji, Mihir ji, Nilanjan ji, Aninda boss ji. Thanks for inviting me for this session. Thank you very much.
And they're all, I kindly request to turn on their cameras for a quick snapshot for this virtual conference. Thank you so much, everyone. Stay safe and take care.
Thank you, everyone. Thank you, Richa. Thank you, Navneet.